Chapter 1-6, Two-Dimensional Figures. We're going to go over the basic of some of the more common two-dimensional figures, including how to calculate their area and perimeter. We'll cover two-dimensional figures more in depth later in second semester. Now, a polygon is a closed figure. It's formed by a finite number of segments that are all in the same plane, and they're called sides. The sides intersect in a common endpoint, which is called the vertex. And each side only intersects in one and two other sides. Our notation for the polygons is this here. We just start with one point here. We started with G, and then we went around clockwise. So we call this polygon GHJKLM. In this course, we'll only be studying convex polygons, or we'll look at a few concave, but all of our formulas and our theorems apply to convex polygons. The difference between convex and concave is that if you draw a figure that is concave, it kind of caves in on itself. And if you draw a line through each of the sides, it intersects or goes through the interior of the figure. If you look at a polygon that is convex, and we'll look at a parallelogram here, if I extend each of those sides, they will not pass through the interior. So that's the difference between concave and convex. So here, some lines pass through the interior. In this class, I'm only going to ask you to memorize the names for sides 3 through 10, so triangle and so forth. Anything above that, you don't need to know the name. How we'll do this in this class is we'll use n-gon. So if you have 15 sides, it'll be called a 15-gon. In most of the homework assignments and coursework and test and quizzes, I'll use like the term octagon, expecting you to know that it's 8 sides. Some questions, though, will list it as an 8-gon. Equilateral polygon, all sides are congruent. Equiangular, all angles are congruent. We will find that if a polygon is equilateral, it's also equiangular. If it's equiangular, it also has to be equilateral. A regular polygon has to be convex. It has to be equilateral. And it has to be equiangular. Irregular, we'll define it as not regular. So either it's concave or it doesn't have equal sides or equal angles. Looking at the first two problems, A and B, we want to name the polygon by the number of sides and classify it as convex or concave, regular or irregular. So for A, we have 4 sides, so it's a quadrilateral. It is convex. But none of the sides are equal, or they're not equal all to each other, so it's irregular. For problem B, if you count the sides, there are 9 sides. So it is a nonagon. Remember, we could also call this a 9-gon. It is definitely concave because if you pick all the sides or certain sides, they go through it. So this is concave. And since it is concave, it has to be irregular. For this next chart is review. We're going to review the perimeter and area of these common polygons that we use all the time. And for the perimeter, we sum the sides. So in this picture, the perimeter would be C plus B plus D. Area of a triangle is 1/2 base times height. You could either write it that way or write it base times height over 2. We'll skip the square for a minute because a square is a special form of rectangle. For a rectangle to do the perimeter, it'd be 2 times the width plus 2 times the length, or you could have done width plus length plus width plus length. The area is length times width. Some of you know it also is base times height, because basically the length and width are both the base and the height. For a square, it's a rectangle with all 4 equal sides. So the perimeter would be 4 times S, because you have S plus S plus S plus S. The area would be S squared. Looking at a circle, R stands for the radius. D would be the diameter. And the capital C stands for circumference. And circumference is the perimeter of the circle. When I ask some of my students what circumference is, the first thing they remember is pi r squared, and that's the area. The way to remember that it's area is that you have a distance, which is radius, times radius. So it would be units squared, which would give you area. Circumference is 2 pi r. Some people memorize it as pi d because the diameter is 2 times the radius. Now, when you do problems, I want you to use the pi key on your calculator. I do not want you to use 3.14. Sometimes your answers become really, really close to what we need and we'll round to the same amount. Other times it'll be a little further off than what we want them to be. So your calculators all have a pi key, including your cell phone. Looking at the first problem, I want to find the perimeter. The perimeter here would be 2 times 2.3 plus 2 times 4.6, which would give me 13.8 centimeters. The area would be 2.3 times 4.6, and that would give me that the area is 10.58 centimeters squared. Units are really important, especially since we're going to be working in terms of, are we looking at area? So is it unit squared, or are we looking at just a length? So it wouldn't be unit squared. Looking at the circle here for problem B, circumference would be 2 pi r, and the radius here is 4. So the exact answer that's not rounded would be 8 pi inches. Now, I want you in all your work to get used to putting down the exact answer, and then you can put down the rounded answer. But exact answers are going to be what a lot of math and a lot of science will call for as you progress through high school and college. Looking at the rounded answer, I would put 8 pi into the calculator, and I would get that it's approximately 25.1 inches. So there's our circumference. Area is pi r squared, so the exact answer would be 16 pi inches squared. The rounded answer after I put in the calculator is, just a second, 50.3 inches squared. And we do have a few symbols that we've talked about. This is equal, which means two measurements are equal. This is congruent, which means two items are alike, are congruent. They're the same measurement. This means approximation, the two tildes together. For the next problem, Terry has 19 feet of tape to mark an area off in their classroom. Which of these shapes have the perimeter or circumference that would use most or all of the tape? A square with a side length of 5 feet. The perimeter would be 4 sides times 5, which is 20 feet. And that's too much, so we've ruled out A. Circle with a radius of 3 feet. So the circumference would be 2 pi times 3. The exact answer would be 6 pi feet. That's not enough for us to tell whether it's 19 feet or less. So the circumference, putting it into the calculator, gives me approximately 18.8 feet. So far that one fits. Let's see if we can get something that's closer. A right triangle with each leg of 6 feet. So we have 6 feet, 6 feet. We need to find the hypotenuse here. We call on Pythagoras to help us with the Pythagorean theorem. So we would have x squared equals 6 squared plus 6 squared. A lot of you remembered it as a squared plus b squared equals c squared. So now I have x squared equals 36 plus 36 is 72. To solve this, I would have to rad or square root both sides. All this year, I'm going to put the plus or minus in front of the square root when you do this type of problem because there are two answers to it. I know we're looking for a measurement for a geometric figure, so all we're going to use is the positive answer. But the reason I will continue to show that all year is because when you go to Algebra 2 next year, if we don't do that, then you're going to forget to do it, and you will be counted off for your problems. So here I have that x is rad 72, which is approximately 8.5. So I add the 3 sides to get the perimeter. And the perimeter is approximately 20.5 feet. Well, that one rules that one out again because it is greater than 19. So we have one last one to check, and that's a rectangle. So the perimeter would be 2 times 8 plus 2 times 3, which is 16 plus 6, which gives us 22 feet. So that rules that one out also. So our answer would be B. On our last question, we want to find the perimeter of the area of the pentagon ABCDE. They've graphed it already for us, which makes it easy. We do have to find the length of each side, but since it's graphed and we can just count these points on the horizontal and vertical lines, it saves us a little work in putting those into the distance formula. So the length of ED would be 1, 2, 3, 4, 5. The length of DC would be 1, 2, 3, 4, 5, 6. Now we need to figure the length of EA. And looking at the length of EA, we have E is the point -3, 1. A is the point 0.04. Using the distance formula, which is the square root of the x's, differences in the x's squared, plus the differences in the y squared. So here I have -3 squared, which is 9. -3 squared again, which is 9. So I have the square root of 18. Then I'm going to need to find the distance of AB. And for the distance of AB, I have that the point B is 4, 0. So find, whoops, I did too much here. So looking at that, I have the differences in the x's squared plus the differences in the y squared. So negative 4 squared is 16. 4 squared is 16, so I have rad 32, or the square root of 32. As you notice, I'm not putting the rounded answers here because I don't want to round too early. If you desperately have to round it, then round it out because you know you're going to be adding these together to at least like the thousandths place. So the last one we have is BC. And with BC, I have the point C is 3, negative 4. So we have the differences in the x's squared plus the differences in the y squared. So I have 1 squared, which is 1, positive 4 squared, which is 16. So I have rad 17. To find the perimeter, I would add all the sides. Now for this one, I know I have 11 here, but you can enter in all at once into your calculator by doing 11 plus rad 18 enter, plus rad 32 enter, plus rad 17 enter. So you're not rounding to the very end. If you have the TIs, you can type it in as 5 plus 6 plus rad. When that symbol comes up, it comes up with the parentheses. Type in the 18, close it. You need to remember to add the parentheses. The same with the rad 32 and the same with the rad 17. You have calculators that can give you exact answers now. I mean, less error with the answers, and you take the rounded answer at the very end. And so for here, I have the perimeter is approximately 25.0 units. Now to find the area, I'm going to have to divide this into figures that I can easily find the area of. So if I draw a line right here, horizontal line, let's name this point F, I have a triangle where I do have a base and I do have a height. I will draw another line here to make another triangle. So I have a base and a height. And then I will have the rectangle there. So looking at triangle EAF, I have the base is 1, 2, 3, 4, 5, 6 times the height, which is 1, 2, 3 divided by 2. So that area is 9. So I have 9 right here for this area. For triangle FBC, I have the base is 1, 2, 3, 4, 5 times the height, which is 1, divided by 2. So this is 2.5. And then for the quadrilateral EFCD, I have 6 times 5, which is 30. So this area right here is 30. The area of this here is 2.5, and the area of the top triangle is 9. So to find the area, I'll add them, 9 plus 30 plus 2.5. And that gives me that the area is 41.5 units squared. And that concludes the lesson for 1-6.